Now, let's go on to a demo. A demo on the placement activities. So we'll be performing this demo and seeing in the recommender system that whether a student will be placed or not. So first, as we saw, we imported the data and then we saw the data head. Now let's move to the second step, that is data pre-processing. So how do we process the data? So first we process the data and we see we don't need this column of SL number. So we drop the serial number by the following function. We say which shape 15 to 2. We see the shape of the data set would be 15 to 25 and then we would just drop the data set. We drop the SL number and after using the ilog function, which is explained in operation in pandas. And after we drop the data set, we then see the shape of the data set. The shape of the data set is set to be 215 to 14, where here the data set was it said it is 15 columns, but here we have 14. Now we have unique values of categorical features. So we take the information and see what is an empty column. So we have 215 non-null values and salary has a lot of empty data set. So then we train the data columns and we see what are the columns present in the data set. So we have gender, percentage, secondary school percentage, high school percentage and board, and then we have degree percentage and the technical field. We have the work experience, we have estimated percentage, we have specialization, we have MBA percentage and the status and the salary. Now let's take the unique values of all the other data set. Of all the data columns, we took a unique value and we saw we have others and central and we have secondary school board. And then we have commerce, science and arts in the high school board. And then when it comes to degree, we have science and tech, commerce and management and others. In specialization and work experience, we have yes or a no. In specialization, we have two types of specializations, people that have marketing and HR and marketing and finance. And then finally, we have the status, whether they are placed or not placed. Now we go on to find the null data set. Now how do we find a null data set? We saw we have null data set here in this salary part. Now let's again find the null data set by seeing the sum train underscore data is null. This is an operation which involves a panda library. So we see the sum of all the null values. So the sum of all null values present only in the salary part. So now let's separate salary exploration of data. We're performing explanation of data and we'll be dropping the salary part. Now when we say null salary data, train the data set and train salary, not NA. So we train the data which is false, which is not null, and we drop the value which is null. Now let's see the status. Let's see the status value count. We can visualize the data, which is the second part of our process in recommender systems. So first we visualize the data, saying we visualize the status part of the data, which is very important. So they say they have placed as 148 people and non-placed people are 67 people. Now we'll print the salary count. So we can see the amount of salary people have got. We see maximum people who are 22 have got a salary of 3 lakh rupees. And the minimum salary and the maximum would be 3 lakhs. One person has got the salary. Now we'll be visualizing the data of the senior secondary board. So here we visualize the data and we count the number of board results people have are central. How many people are central and how many people are others would be 166 are central, 116 are central and 99 are others. We'll be seeing the similar for higher secondary school board. So higher secondary school board has others as 131 and the central as 84. And then now we're looking at the higher secondary subjects. The higher secondary subjects, the data that people have taken would be commerce, science and arts as we saw. So now let's calculate the value. We calculate the value as commerce would be 113, science would be 91, arts would 11. Now let's calculate the work experience. So the people had two types of work experience. That was either they had a work experience or they did not have a work experience. So here, when we see, we have 141 people who did not have a work experience, and we have 74 people who have a work experience. Now let's look at specialization. We know people were specialized in two fields in the MBA column, which were marketing and HR and marketing and finance. Now we'll be printing out the specialization value count for each of the marketing and HR and marketing of finance, which would be, we have 120 in the marketing and finance, and marketing and HR has 95 people. Now we move on to categorizing this data we have visualized. So let's apply one-hot encoding on the gender values. We have the gender values as male and female. Let's apply one-hot encoding on the gender column. So we have gender. If gender is equal to male, it's 1. If its gender is equal to female, it will be shown as 0. The same one-hot encoding on the secondary school board, high school board, the degree taken, the work experience, the specialization as well. Now we apply one-hot encoding except salary. We have salary again here, and now we'll be performing label encoding on the status. After performing specialization, we took in the status and we perform label encoding where it said whether if it's placed, it's 1, and not placed, it's 0. And now when we print the data head, we see the status has changed from placed and not placed to 1 and 0. Now, as the salary column has a lot of null values and isn't much required, so we'll be dropping the salary value column here. So we drop the salary column and we add another one-hot encoder to all the final trained data set. So the new data set would be a final trained data set, which would include gender, secondary school board, high school board science, central and others, degree taken, work experience, specialization. And then we'll be printing the head. So here we get it. Here we get the gender, M, which whether they're male or not, secondary school board others, high school board others, high school board commerce, high school board science, and then we have degree taken others, degree taken science and tech, and then work experience, which is yes, and specialization in marketing and HR. And then we have this, it is combined on the axis of status. After combining the data set, we drop the unnecessary data set as a gender, SSC, the secondary board percentage, the secondary board marks, the high school percentage, high school board marks, and the degree percentage. After dropping this, we drop and view the data. After we drop and view the data, we train the data set and we find the shape and the column of the data set. Now after we have the data set, we have shape and column. And after this, we see the columns we have. The columns included are the secondary school percentage, the high school percentage, degree percentage, and then we have the estimated percentage, MBA percentage, status, gender, which is male, and the other board and the commerce, and we include the work experience and specialization in marketing and HR. And then let's prepare our final data set. So to perform our final data set, we include the index of the data set of the final trained data, and the prediction should be on status. So we have to predict whether the student will be placed or not. So we will be predicting that in the Y column. So the x-axis is assigned the index except the data and except the status, and the Y column is assigned the status. Now let's split the data. So to split the data, we'll import a test and train model from the sklearn model selection. And after we import the test and train split, we say the test size to be 0.1 and the random state is 25. We saw in the logistic regression example, we performed logistic regression. So we'll be combining this logistic regression to the data set, and then we'll scale the model. So we use scalar and scale the model. We perform XGB classification on the model first. Okay, so we have an error here which says x_train is undefined. We forgot to run the cell, and yes, when we run the cell, we get the logistic regression as 0.1. Now we have XGB classification, and yes, So now we have XGB classifier. We import XGBoost, which is used for boosting our classification. Though as the accuracy is 81%, let's boost our accuracy now. So to boost our accuracy, we call an XGB classifier. So we predict the X test and we get the accuracy score. So we say XGB prediction to be the underscore X test with the values to be tested on the data set. And after this, we apply a gradient boosting method. In a gradient boosting method, we'll be seeing on how we can boost our classification. Gradient boosting classifier accuracy, we first import the sklearn assemble from the gradient boosting classifier, and the gradient boosting classifier is assigned as g by k. After gpk.fit xtrain underscore ytrain, and then the prediction is made using the gkb predict on the x dataset, which is used for testing, and then we print the accuracy of the dataset. So we get the accuracy under the gradient boosting classifier to be 90%. And now finally we'll test our data. Does this work for other data sets? So let's train the data and check with our existing data set first. So we say model is equal to logrec.fit of x underscore train underscore y, and model.predict. Let's predict the fourth value. Let's say x train of 4. So if we say x train of 4, we'll determine whether the fifth person in the row would be placed or not. So let's call the y train.head of the first 10. Instead of 10, let's call 4. It says array is 0, that means the person is not placed. And here we have 1, 2, 3, and 4, and it says a person isn't placed. So our model is absolutely right. Now, when we have checked our model and we have checked yes, it's accurate, let's see how it can predict for a new data set. So now we import a new data set which includes new student, and it includes all the values of being 10th, 12th, and the degree and the MBA specialization marks with the gender and the other details required. So we given 14 we import 14 values here, and then we go on to predict the status of the student. Let's change this a bit and let's now predict if the student is placed. Yes, the student is still placed. So we have seen on how we can put a demo on placement activities and how the student can be placed. Now we know that our model is precise and we did it is accurate as well. It has an accuracy of 90.9%, which is a good value as well. You have any questions and doubts regarding the video, please comment down below. Thank you so much for watching the video. Hit the like button, subscribe, and turn the notification on to stay updated with new videos coming up on the way. Thank you.